Well, welcome to another edition of TechTime. And today we're going to talk a little bit about some compressor windings and some solenoid testing. Appreciate you taking your time out of your workday. Got any questions? Here's some websites you can give us, send us an email, give us a call on anything that we do. Tech support's here to help take care of any questions you guys may have. You hear from me today. I'm Jim Strandlund, one of the technical services specialist teams. Our phone numbers are there if you need to get a hold of us. If you don't have it, my email is there as well. If we can help you out, let me know. We're hosted by Intertech University, intertechuniversity.com, and you can get into our YouTube channel. We got a bunch of these programs and trainings there for you to watch. And here's our technical service members team. Changing daily, but we got a good crew out there to help you out. Just give us a call. And don't forget that the support site we have nowadays, service techs can be added to that, and there's a lot of detailed information and helpful for them there. Contact your territory manager, your company guys, and get your members signed up for it, all your workers and employees, etc. So we'll talk about things about compressor windings on a three-phase compressor bearing unit, okay? Most all of Intertech's variable speed geothermal heat pumps use an inverter-driven compressor today. This gives us the availability for unlimited speed ramping with engineers' design parameters and increase our efficiency of operation. Testing a three-phase compressor is different than a regular reciprocating compressor. Three-phase compressor still has a three-terminal post like the reciprocating compressor. The differences in the resistance or ohm readings. Three-phase terminals should have equal resistance between all terminals. The reciprocating will be of different readings. Remember, every person's voltmeter, amp meter, ohm meter may be a little bit different, so we want to get really close. But using a good meter is going to be very critical in your testing. Sometimes it's also in our units hard to reach the pins, so we really like to recommend using the alligator clips as showing here. It doesn't really matter what color you put on there. We'll talk about the resistance read numbers and what that means for which terminal is what here in a second. As you can see, I put those alligator clips on the posts, run them out, and I did my testing with them from there. My first reading, I had hit 0.4 ohms, I believe, 0.4 ohms on this three-phase unit. The second reading, I hit 0.5, and I'll show you a diagram here in a second to make it a little more clear. Recommend taking a piece of paper and pretty much drawing like this here. Get the three post terminals out there, and you can measure the readings in between them. Mark them down. All right. Third reading was a 0.7. So the three measurements I have are between those three terminals. This is what I had accomplished on a three-phase compressor that I have in my possession. They're not equal, but they may be close. But this compressor turned out to be bad. There's enough difference in there that caused the inverter drive to have faults. And so the compressor had to be replaced, and it worked fine. One thing to remember when using your ohm meter, do not use the megohm setting. False readings can be obtained, and we had talked about that on an earlier tech time that you can always go back and revisit and view. Okay, the single phase compressor testing. Okay, the plug on the compressor actually dictates and shows you the red, the black, and the yellow terminals, which one is a L1, L2, L3, or run common and start winding. So if you don't know that or don't see it, it's really easy to determine which one is the common, which one's the start, which one's the run. Again, we'll be taking some measurements here. And again, using your trusty ohm meter. This is a water-to-water unit with the side panel and top panels off. These ones are kind of hard to reach those terminals. That's where these alligator clips come in real handy. So it helps you allow to take some of the measurements from the front without removing all of the panels. Measuring all 3 terminals, document them again. I'll show you this in a second. Make a triangle, mark the points, take the measurements, mark them in. It'll help you determine what is what. So again, talking about this, the readings determine which one is the start winding, which one is the run winding, and which is common. So the measurement between, on this diagram, the red and the yellow was 2.5. That is the largest number that we obtained. So we know that the farthest point to your left, the black one, would be the common, because we are measuring the accumulation of the start winding and also the run winding. So then we know where the common winding is. So from the black, say, to the yellow pin, we had 1.9. So that's higher than the 0.6. So that tells me that the yellow mark would be the start winding. And again, the 0.6 would mean the run winding on the red. So that's how you can determine if you don't know which ones are what, by doing your own measurement readings and thinking about which one it is. Well, is it the run winding will always be the lower of the resistance, start winding will be in the middle, and the common will always be the highest number reading. When you start doing on our Copeland compressors, the Y2 or the second stage, second speed solenoid testing, there's an internal solenoid that gets energized from the Y2 terminal typically, which creates the compressor to go into its second stage of operation. One thing to remember, that the compressor power plug actually converts AC electricity to a DC electricity. So you have to measure the power in DC if you're measuring at the plug. I'll show you this in a second. But make sure you have a meter that can read DC voltage as well. And we'll also be able to measure the internal resistance on the pins, 2 pins going into the compressor, and I'll give you some data here on that in a second. The Copeland plug typically tells you that there's a 24 volts AC going into it, but the output is 24 volts DC, because there's a rectifier built into the plug itself that converts it over. So bear that in mind. Now, when we're measuring the resistance, what does that mean? Well, Copeland has an application engineering technical bulletin that will tell you which measurements for the solenoid resistance values there would be. It's dependent upon the model. K4 versus the K5 Copeland scrolls have a different resistance. And I believe I will get a better screen here for you to write down the numbers. The new K5s could have a couple of different resistance numbers when you're ohming them out. All the K4s were at like 33.6 ohms. K5s can be anywhere from 350 or also 1640 ohms, depending on the version. Again, measuring the resistance of the compressor that I have on this water-to-water unit, it came out with 1,573 ohms. And here's that chart that I was talking about. The technical bulletin shows you approximately where those numbers are. Again, meters can be a little bit different or a little bit off. So at least I know I was pretty close to the source A, and that compressor is working good. So numbers to remember are these 3 resistances. If you ever have a question, if you get no resistance, there's something wrong with the internal solenoid, and it may need to be replacing the compressor. Also remember, as most of you guys already know, but check each terminal to ground and make sure that it's not shorted out. Direct ground as well, another way. Make sure you use the measurements on the resistance solenoids or on the compressor windings, and use a good ground, typically on the copper pipe off of the compressor is the best way to do it. Just make sure you double check your values as well. And with that, keep in mind that Intertech University has a complete list All the TechTime recordings are here. The rest of our trainings are here recorded for you guys to watch. Good information. And don't forget, if you got any questions about anything you're on, give us a call. And again, I want to thank you for attending this month's Tech Time. I look forward to seeing you next month. Have a great day. Thank you.